Hey there, so here's where we left off last time. We have our level select screen that we can go to, and we can use this to play a level. The level loads in, and there's a few issues that we need to fix here. First, there's one thing I forgot to do with the camera scaler, so we need to fix that. Second, there's an issue about where things are in the sorting layer, so we'll fix that today too. The main thing we're going to do though is we're going to make this run better so that it's going to be better for mobile builds. Right now it works just fine on the PC, but I've tried porting it to mobile, and so have a few other people, and it doesn't port super well to mobile with the way it is right now. So we're going to go over some tips that you can use to better optimize your Unity project for the mobile platform. So let's fix a few things first here though. In my scene, I'm going to zoom way out and take a look at my UI. These are still stretched, so let's fix that first. Let's go into our main scene here and look at my top UI. I'm going to turn off the fade panel for a second. And in my top UI, I'm going to find my goal container. I don't want to child force expand the width. And my prefabs, I think I did this last time. My goal prefab, yeah, it's got a preferred width of 74. I wonder why it was still expanding it. Goal container. What did I forget to do? What happens if I just hit play? Okay, let's look at this goal image here. No, I wanted the actual goal prefab, not the image. Oh, okay, 74 is way too big for this one. That's why. So let's change that 74 down just a little bit. Let's say 64, and that'll be a nice power of 2. Okay, I'm going to turn my fade panel back on now. Alright, now the next issue that I want to address before we get to optimization is, so this comes in just fine. Okay, so this time the sorting was totally fine, but let's deal with the sorting, because what'll happen, sometimes if you get a bomb made, and that time was supposed to make a bomb, we're going to fix the bombs too. If you're in a situation where there's supposed to be a bomb, like right now, if I take a look at my board, if I zoom in, this blue piece here is supposed to be an adjacent bomb. And the adjacent bomb marker is there, it's just behind everything, so you can't really tell that it's there. So let's fix that. What we want is we want the markers to be higher in the sorting layer, or on even a different sorting layer than the image that's on the actual piece. So the image that's on the piece is on the default layer, order 1, and then this marker is also on the default layer, order 1, which means that they're essentially at the same depth. So Unity will put whichever one was made first on top. So let's fix that. So I'm going to just choose my prefabs. I'm going to go into my piece prefabs, and let's start with that adjacent marker. Over here in the sprite renderer, I'm going to choose the sorting layer. I'm going to add a new sorting layer, and I'm going to call this markers. And I might as well add another one that I'm going to call background. Now, from the way that Unity draws this is whatever is lowest goes in front. So I want the background to be the last, and I want the markers to be the first, and then I think I want the particles to be beneath the pieces but on front of the background. So I think that's the order I want them in. I'm going to go to adjacent, I'm going to put it on the markers layer, I'm going to leave it 1. I'm going to go to my breakable tile, I'm going to put that on the default layer, but I'm going to change its order to -1 so that it always renders beneath the sprites. I'm going to go to my column arrow, change its sorting layer to markers, and I can just leave that to 1 since I've changed the layer. I can go to my rainbow bomb, change that to markers, and put it at 1. And my row arrow, change that to markers, make sure it's at 1. And now I want to look at the background tiles here. So where did I put the background tiles? There we go. So the tile background, I'm going to put this on background layer, and I'm going to put this order in layer at 1. And now I want to look at my hint particle. In hint particle, I'm going to go underneath renderer and sorting layer. I'm going to put these on particles. It's going to be number 1 in that layer. And now what else? The actual background I need to look at now. So I'm going to look at my background canvas, my background image. I need to do this on the actual canvas. So on my background canvas, I'm going to move this from sorting or from default to background. All right, so let's try that now. So that falls in like it should. Okay, cool. This looks better. My marker appeared on top like it should. So did that marker. Okay, so this is better. Now we still have an issue with the camera because this is way too close in. So the problem is when I was writing the camera script, I forgot about one thing. So I'm going to open up my camera scaler script. And once that's open, what I forgot about, if I pop back into Unity here, so the camera size is from the middle of the screen to the top of the screen, but then I added a Y offset as well so that the camera was down a little bit, which means that I needed to add 2 times that Y offset to make everything work the way it should. So in my camera scaler script, I'm going to check to see, so reposition camera, checks to see if the width is greater than the height, and if that's true, it does this. This is fine. It's the else statement when the height is greater than the width. What I want to do here is I want to say that I'm going to do parentheses board.height divided by 2 plus padding, and then I'm going to take this and add to it 2 times the Y offset. And then I'll save that, and if I go back to Unity now, hit play, my board should be much better sized to fit into everything. So, okay, and there we go. That's way better. And if you look at that hint particle now, it's registering on top of the background, but behind the candies. So, yeah, we're good. All right, so now let's talk optimization. So there's a lot of things that you can do for optimization. The first one is the one that I usually save until I'm feeling a little more comfortable with my scripts. If you go into any one of these scripts, and I remember to do it early in the project, but I started getting sloppy later in the project. So if I take a look here at my scripts folder, if I look at my UI scripts, I think some of these have it. So, yep, here we go. So any function call that isn't used is going to have a small amount of memory allotted to it. So the first thing that you can do to up your performance is to delete all of these empty function calls. And that'll happen a lot with start and update because those both get created when you create your new script. So if you're not going to use start or update, make sure that you're deleting those methods. It saves up, I want to say, like 12 bytes of memory per function call, which sounds really small, but it can add up. So that's the first thing we can do. But before I do that, I forgot there's one thing I wanted to get you guys acquainted with. So in the window menu, there is something called the profiler that we're going to be using, and I am just totally missing it. There it is. The profiler tells you what's using memory and how much memory it's using when you're running your game. So we're going to use the profiler kind of as a way to benchmark how successful we're being at saving memory. So if I hit play here, you'll start to see what looks like a seismograph show up. And that is telling you essentially how quickly your game is running. So see at the very beginning there, let me pause this. At the very beginning there, I had a spike of 15 frames per second, which if you know anything about video games, you know is very, very low. And then it dropped down to what looks to be about 80 frames per second consistently, and then it spiked back up to 15. Now, if I keep this up, so let's especially look at what happens when I have bombs or something that destroys a lot of pieces at once. So we'll do that, and then this. And you'll see, again, that spike that was right there. There's a few things that are causing that spike. The main thing that's causing it, one, is the size of the sprites that I've given you guys. The second thing that's causing it is the garbage collector. Unity uses something called a garbage collector that comes through and destroys objects or creates objects. So whenever you use the function call instantiate or the function call destroy, that garbage collector is being summoned, and the garbage collector takes a ridiculous amount of memory. It's one of the problems that Unity has, is the garbage collection system is very inefficient. So what we want to do is we want to do stuff that's going to limit the garbage collection. Now, the first thing that we can do is going to affect that garbage collector when we're instantiating objects. So when I created this art, I created it nice and high definition. I made it look really good full screen, but it's way too big than what anybody's going to be able to notice on a cell phone screen. So what I need to do is I need to change my texture compression so that I'm cutting my texture way in half. So I'm going to go to, for me, it's under Edit, and then Project Settings, and then I'm going to go to Quality. So this is the first thing I'm going to edit. Now, I'm building this for Android, so I'm going to focus on the Android symbol. This is the iOS symbol. This is download to PC or Mac, and then this is build for web. Now, there's really no reason I need to go any past the medium specs, so I'm just even going to erase the high, very high, and ultra specs for this, and I might as well do the same thing for iOS. They're not even an option. And oops, I want to focus on the medium here, which is going to be my preferred rendering specs for Android. And I'll leave my pixel light count alone, but my texture quality, instead of being full res, I'm going to take that down to quarter res, which sounds like a huge cut, but since the art I provided was 512 by 512, taking it to quarter res takes those sprites down to 128 by 128, which is still really big for most phone screens, especially if you have it like, 10 things wide. There's no phone screen that has it, 1280. At least I don't think there's one that's 1920 by 1080, but anyway. We're going to take any anisotropic textures and disable them. Anti-aliasing is disabled, but we're going to make sure it's disabled. We're going to make sure soft particles is turned off. Same thing with real-time reflection. Billboard's face camera, we can leave that alone. We're going to disable shadows. Because even though we're not using 3D, that shadows is still taking a tiny bit of memory. Shadow resolution, shadow projection, shadow distance, near clipping plane. Done weight. Okay, I think that's all I want to change in the quality settings. Now, the next thing I want to do is going to be with the player. And so those are going to be the settings that Android has. So again, I'm going to go to Edit, Project Settings, and I'm going to choose Player. Make sure that Android is selected. In my color space, I'm going to leave that as Gamma. Make sure that multi-thread rendering is on. I'm in other settings right now, in case yours didn't come up the way that mine did. We don't want to do GPU skinning, graphics, protect graphics memory. All of that should be fine. The architecture shouldn't cause any problems, and the logging should be fine. So get resolution and presentation. Okay, so allowed orientations. I didn't build anything in for landscape, so I'm going to remove the landscape orientations. I'm also going to take away the 32-bit display buffer because that also takes memory we're not using, and make sure that the depth and oh yeah, disable depth and stencil. And I'm also going to just say to show the loading indicator so that in case there's a long load time, the user can get a little loading indicator. We can make a custom one, but for now, that's that. Okay, cool. So now, just making those changes, if I hit play, let's see what happens to our frame rate. All right, so still not great. We're having some dips back to 15 again. And it's the garbage collection, I bet. So what happens is when Unity needs memory, it will wait until it's completely out of memory before it'll run the garbage collector. And then the garbage collector will collect everything at once, which isn't very efficient. So I want you guys to open up your base game script in the board script. We're going to call the garbage collector ourselves so that it's not piling up like it is right now. So in the board scripts, I'm going to go down to, oh yeah, there's one more thing I wanted to show you guys. I've already have it enabled here. It's something called code folding, which makes big scripts like the board script much more easy to navigate around. So to do this, we're going to go to Preferences, and then Text Editor inside Preferences, and then General. So again, that was Preferences, which for me is under Visual Studio Community. On Windows, I think it's under Edit, and then choose Text Editor, General, and then click this box that says Enable Code Folding. So what that allows you to do is I can fold all of these, I don't want to fold board, but I can fold these methods so that I can see their name, but I don't necessarily have to scroll by all of it. Okay, we'll get rid, or not get rid of, but fold. Let's see, decrease row, refill board, matches on board, and it's fill board coroutine that I want. So in here, what I want to do is before I change the game state to move, I'm going to call the garbage collector myself. And to do that, it's system.gc.collect. Oops, no, not add memory pressure. There we go. And so that's going to automatically call the garbage collector. Now, while I'm seeing it, the next thing that we can do is we can get rid of every debug statement that we don't need. So all of these debug statements we're not using anymore. I have a tendency to leave them until I go through and start cleaning up my code. Debug statements take, I want to say it's 32 bytes per statement at least, but it can go up from there. So your debug statements could take as much as, I don't know, I want to say like 128 or 256 bytes, which doesn't sound like a lot, but again, it adds up. So let's see here. I have debug statements in my setup method, where I'm debugging the max iterations. So take that out. And I have a debug statement in my fill board coroutine, I think. No, it's not fill board. It's destroy matches. Where was that? Is it in destroy matches? It must be in destroy matches. Okay. No. Huh. One of these has another debug statement. I think is deadlocked might. No. Shuffle board might though. Wait, I saw it. There we go. Debug.log max iterations. Okay, cool. Alright, so we're manually using the garbage collector now, and we're also removing any debug statements. There are more debug statements to remove, but those are the ones that I know of right now. So I'm going to save my script, go back to Unity, and I'm going to hit play here, and let's see if that affected our performance at all. Okay, so that spike, when there's a spike right there. But those spikes that used to go up to 15 frames per second, those only went up to 30 frames per second now. And as I'm playing, I can see these spikes are now going to something like 20 frames per second. Let me do something here. Make my life a lot more difficult. I'm going to take this blue one right here. I'm going to make this a color bomb, because that's where some people had mentioned that they saw the most difficulty. So if I swap that, okay, there we go. So we're still hanging near 30 frames per second, but this still isn't all that you can do to maximize your performance. So the next thing is kind of fiddly, but when Unity created their UI system, they created it with the idea that everything could be used interactively, every single element in the UI, which means that everything that you create in the UI system has something on it called a Recast target. And so things that we don't want to be able to interact with, we need to remove this Recast target, because again, Unity sets aside a set amount of memory for each of these. So I'm going to my background canvas, my background image. I'm going to turn off Recast target there. I'm going to go to my top UI itself. That itself does not need to be interacted with. My score text doesn't need to be interacted with. Oh no, I still want best fit. I just don't want it to be a Recast target. Score bar doesn't have to be a Recast target. Goal container doesn't have to be a Recast target. Moves label doesn't have to be a Recast target. Time label, not a Recast target. Counter, not a Recast target. Same thing with all of my fade panels here. Even if they're disabled, they still take a tiny bit of memory when they boot up, and that little bit of memory can add up. The OK button we don't want to take the Recast target from, because that's interactable, but the goals panel, the text, Recast target, the goals container, Recast target, the try again panel, the inset in the try again panel, the you win panel. If I can click on it, there we go. And the inset in there. And then also inside the insets, the text shouldn't be Recast targets. There we go. Okay, cool. And now if I go to my prefabs here, I want to look at my goal prefab. I want to make my text not a Recast target, my image not a Recast target, and the prefab itself not a Recast target. So none of those are Recast targets now. So there's a little bit more memory from that. And then the last thing I forgot to do when we were in our player settings, if we go to Edit, Project Settings, Player, I'm going to close resolution. Let's go to Other Settings. I'm going to untick Auto Graphics API, and I want to remove OpenGL ES3 so that it's just OpenGL ES2. And then leave multi-threaded rendering. All right, so I'm going to save my scenes, save my project, and let's see what kind of impact we had. Okay, so general gameplay here. So we still had that big spike when we first started. We had another big spike there. What else can we do to fix this? Okay, here's what the problem was. I'm recording on my laptop like I always do, but I always forget how much system resources the capture software takes. So I just ran it without the capture software, and as you can see, it ran stable at 100 frames per second, but all those spikes that used to be at 30 frames per second are now right around 60 frames per second, which is acceptable. So that means that if you port this to a mobile device, it's probably going to work significantly better now. There's a bunch more that you can do, and a lot of these tips are things that I usually do, like changing the texture size. Some of them were taken from an article that was suggested by a viewer, Kevin Wulf. So we can thank him for some of these tips. And there's so much more that you can do. But yeah, so just to go through what we did, removing empty methods, remove debug statements, make sure that the resolution and presentation is set to how you want it to be. So you want to cut your texture quality, turn off all your shadows and stuff. Even though we're not a 3D game, Unity is a 3D engine, which means it automatically dedicates a small amount of memory to stuff like that. Remove graphic raycasters from the target, call garbage collection yourself, and yeah, that's how you can optimize your project for mobile. So if you have any questions, please feel free to leave them down below. You can follow me on Twitter to find out when I post a new video. You can join the Discord, where I haven't been chatting very much often, but I have usually been chatting about once a day. And yeah, have yourselves a wonderful day.